Hello Math 130 students, we are going to pick up on page 4, section 8.2, Introduction to Inverse Functions. So the first thing we're going to talk about are our one-to-one functions. A one-to-one function is a function that is each element in the range corresponds to exactly one element in the domain. For a horizontal line can be drawn so that it intersects the graph of a function at more than one point, then the graph is not a one-to-one function. If a graph passes the horizontal line test, then it is a one-to-one function, which means at most one horizontal line can cross the graph at most once. So here is our visual. This diagram is a one-to-one function. And the reason we're looking at this function here is because when we draw a horizontal line, and hopefully you guys remember that the definition of a horizontal line goes left to right. So if I draw a horizontal line through it, right, here's my left to right, then if it only crosses it once, then it is a one-to-one function. Versus when you have not a one-to-one function, that means we're looking at this graph. This graph happens to be a parabola. And if I draw that horizontal line, it crosses it twice. So crosses more than one time. So therefore, not a one-to-one function. Okay? So let's think about this. We also know that if f of x is a one-to-one function, meaning it passes, the horizontal line test, and also that, what was the other definition? That each element in the range corresponds to exactly one element in the domain, then it's going to be a one-to-one function. Oops. Okay, so we are looking at these ordered pairs. And we want to know whether or not this is a one-to-one function. So remember, we're trying to determine whether or not this is a one-to-one function. So if it is a one-to-one function, then that means, from our definition, that the x values don't repeat. Okay. So that's our first criteria, and our second criteria is that our y values don't repeat. Okay, so the x values don't repeat and the y values don't repeat. So let's see. I have my x values. So I have 15, negative 11, negative 20, negative 17, negative 5, and a 22. So the x values don't repeat, so that's perfect. Once you know that the x values don't repeat, then you know that it is a function. So that's great, okay? So now we're going to check the second criteria. And the second criteria is the y values don't repeat. So let's check that. So 1, 15, negative 2, negative 3, 5, and a 3. Those don't repeat either. So since it is a function, and we also know that the y values don't repeat, so this is a one-to-one. Okay? So this relation is a one-to-one function. That happens to be true because the x values and the y values don't repeat. Looking at number 2, it's the same thing. So we are going to check whether or not something is a function. So making sure that the x values don't repeat. And don't forget to check if it's one-to-one. Not only does it have to be a function, that's the first criteria, but the second criteria is that your y values don't repeat. So let's check it for our function first. So I'm looking at all of our x values. Now I'm going to see whether or not any of those repeat. None of those repeat, so it meets the criteria of it being a function. Perfect. Now I'm going to look at my y values. So now that I'm looking at my y values, I want to see if any of them repeat. Well, this is y is equal to 17. And this is y is equal to 17 as well. So here, the y values did repeat. So it fails this criteria. So we definitely know that it is a function, but it's a function that is not one-to-one. Because it was not a one-to-one function. It's a function that was not one-to-one. Okay, so let's go ahead and take a look at number 3 then. So for number 3, same process. So it's like, okay, so we want to know whether or not something is a function. So x values don't repeat. And the one-to-one, not only does it have to be a function, but the y values don't repeat. So let's take a look at all of our x values here. So if I'm looking at the x values, do any of them repeat? It does. Here and here it says the x is equal to a negative 13, so it repeats. So it fails it being a function. So the relation is a one-to-one function? No. The relation is a function? No. I didn't even have to read the rest of that sentence, right? If it's not a function, it definitely cannot be one-to-one. And then the third option, part C, is the relation is not a function. So that is the only choice that we have, that the relation is not a function. So we can also use the horizontal line test. So remember, the horizontal line goes left to right. This is a horizontal line. So if it passes at most once, then it's a one-to-one function. If it goes through it twice, then it is not a one-to-one function. So here, we're going to look at the graphs, and we're going to determine whether or not it's a function and whether or not it's a one-to-one function. So here, if we want to know whether it's a function, the other definition of a function other than the x's don't repeat is that it passes the vertical line test. And the vertical line goes straight up and down. So that determines whether or not it's a function, and then the one-to-one does the horizontal. So let's take a look. Let's see whether or not this is going to be a function. So if I were to draw any vertical line, it crosses it once. So I can definitely say that this is a function. Now I want to see whether or not this is going to be a one-to-one. Well, if I were to draw a horizontal line going straight across, it crosses it here once, 2, 3 times. So crosses more than 1, which tells me it's not a one-to-one. So let's look at our options again. The graph is not a function and is not one-to-one. No, we know it's a function. Part B, the graph is a function but is not one-to-one. So that's exactly what our option is going to be. So our option is B. Graph is function, not one-to-one. Okay. So let's take a look at number 2. Let's see whether or not this is going to be a function. So if I draw a vertical line, it passes it once. So here I'm going to say this is a function. And you might say You might say to me, hey, well, what about over here? What if I drew a vertical line going here? Well, if it was perfectly straight, it only crosses it once. And even if I did it right over here, it only crosses it once. So these asymptotes, that's what these are called, asymptotes, they get closer and closer to the axis. So it's not like they're going like a straight thing, right? It's actually curving, 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 curving. So we get closer and closer to the axis, but we never actually get there. So that's why it is definitely going to be a function. So let's determine whether or not this is a one-to-one. So if it was one-to-one, I would draw my horizontal line test, and that crosses it once as well. So this is also a one-to-one function. And you might, again say, well, what if you were to draw your vertical line, or sorry, your horizontal line going this way? Again, it only crosses it once because it's an asymptote. It gets closer and closer to the axis, but never actually touches it. So therefore, this graph, you would say, is a function. This is a one-to-one function. So this would be letter C. It's a one-to-one function. And to be honest, letter D, the graph is a one-to-one, but it's not a function. That's not even possible. You cannot be a one-to-one if you aren't a function. If you're not a function, you cannot be one-to-one. So just know that D is an option, but it's as that's listed, but it doesn't actually happen. There's no way that can actually be happening. So let's look at two more. So we want to know whether it's a one-to-one, a function or not. So letter C, if I know I'm looking at a function, here is my vertical line test. So I cross it twice, so it fails the first criteria. This is not a function, so A, not a function. And if it's not a function, it definitely can't be one-to-one. All right, so now number 4. I'm looking at this, and I'm going to draw a vertical line. So again, here, this graph is not a function. Okay. To find the inverse function of a one-to-one function, well, here are the steps. It boils down to 4 of them. So for example, number 1, it says to find the inverse of this function f. Well, what is happening with this function f? All it is it listing ordered pairs. So it lists a group of ordered pairs. Which is great. So it specifically wants to see, well, it says to find the inverse. So what you do, so for part A, the inverse, what you do is we are going to change this notation. We want to change f of x into the notation f inverse of x. So this represents the inverse of f. So in math, we always use symbols. So that symbol says the inverse of f. So first of all, my notation. So I have f inverse of x is equal to, and since it's a group of ordered pairs, I'm still going to have ordered pairs. Now the only difference here with the ordered pairs is that this is going to happen. We are going to interchange or switch the x and the y values. So if I'm looking at this first ordered pair, which is here, I have my x value and I have my y value. So what I'm going to do is I'm going to switch it. Now I'm going to have a -3, -1. So, okay, well, here's my second, where I have my x and my y. Well, now I'm going to switch it, -7, -5. So I keep doing that for all of my ordered pairs. So I have -8, -6, and I have a -12, -8. And I close it with those braces, right? So what I did is I took each ordered pair and I switched the order. So that is going to be my inverse. Now for the second part, it specifically says to determine the domain and range of the inverse function. So okay, so if I'm thinking about the domain are all of my x values. So my domain is going to include -3, -7, -8, and -12. So -3, -7, -8, and -12 are all of the x values in my f inverse function. Now, if I am looking for my range, the range, don't forget, were all of my y values. So, instead of looking at the x's, I'm going to be looking at the y's now. So all of these elements are going to be values in my range. So I have a -1, a -5, a -6, and a -8. And it says, use a comma to separate the ordered pairs and numbers. Oh, okay, so I already did that. There's commas everywhere. So I have my inverse, I have my domain, and I have my range. For number 2, we are actually going to be following the steps that was outlined, right? So the first step says, replace f of x with y. So, okay, so I need to change that f of x with the notation of y. So I'm going to have that this is equal to y is equal to x cubed minus 4. Now, my step number 2 tells me to switch the x and y variable. So I'm literally going to switch it. So this is going to be x is equal to y to the third minus 4. I had switched the x and y value. Now, the third step says to solve the equation for y. So, okay, well, I'm going to solve this for y. So, I'm going to add 4 to both sides, and I get that x plus 4 is equal to y to the third. To get rid of that third exponent, I'm going to raise it to the 1/3 power. So now I get x plus 4 to the 1/3 is equal to y. So this is the same as saying that y is equal to x plus 4 to the 1/3 power. Because I have a 1 in the denominator, 1 in the numerator, then that tells us that this is going to be a root. Okay? So here I'm going to have y is equal to x plus 4, and since the denominator is 3, that is going to be my index. Okay? And so the last step here, it says to replace y with f inverse. So you just found the inverse, right? So now I'm going to say that this is equal to f inverse of x is equal to the third root of x plus 4. And that ends up becoming your final answer. For example number 3, we are going to follow the same steps. So step number 1, change it to y. So y is equal to -3x plus 5, and I have my index of 5. So step number 1, change it to y, did that. Now step number 2, switch your x and y variable. So x is equal to -3y plus 5, fifth index. So if I am going to solve for y now, I'm going to raise everything to the power of that index. That would give me a 5. So now I have x to the fifth power is equal to a negative 3y plus 5. So subtract 5 from both sides, so that x to the fifth minus 5 is equal to a negative 3y. From here, divide by a negative 3. So that x to the fifth minus y divided by negative 3 is equal to a y. So I'm just going to rewrite what I have. Y is equal to x to the fifth minus 5 divided by negative 3. And that last step is to switch it back to my proper notation. So f inverse of x is equal to x to the 5 minus 5 over negative 3. And that is the end of section 8.2. Thank you.